Friends, welcome back. Under 7 tools of quality heading, I already explained you about process flow diagram and Ishikawa diagram. Now I want to explain you about very important aspect is control charts. What are control charts? Where it is to be used, why it is to be used, how it is to be used. That best part is how it is to be used. I will show you actual process to create a control chart. So which will determine upper control limit, lower control limit, how should you define the UCL, how should you define the LCL, how you should monitor your working or process, whether it is really working or it is going out of the control. So the control charts, another tool of quality. Control chart is the best tool for evaluating your process performance, whether it is really working or it is going out of hands or it is underperforming or overperforming, how it is doing. That you will be able to assess and analyze with the help of control charts. Apologies. It can be used at organization level for process monitoring and help to determine some of the factors like stability of the process and its trend. We know process stabilization takes some time, so you can really use control charts through UCL and LCL to understand whether the process is really stabilized or it also helps you the predictability of process as symptomatic evaluation. This is giving you the symptomatic results, so you can really understand how your process is going to work. It also helps you to identify the common cause of variation by using other tools in integration. For example, at some particular day or some time your process is going out of hand, you can really use different tools, Ishikawa diagram, you can use 7y tool, 5y tool, or some other tool to analyze what is the problem, what is the root cause, and why your process is going out of the turn. Then define trigger points to identify special condition to initiating action. So you can really analyze on one particular day if your process is going out of hand, then what was the special condition under which your process is getting triggered to cross UCL or LCL. So these are the standard methodology and these are the uses of control charts. So guys, these some of the components of control chart is control limits. Generally we call it UCL, upper control limit, LCL, lower control limit. UCL or upper control limit and LCL is lower control limit. These limits are derived from statistical analysis using historical database from organizational process set. Or this is organization level, right? Though there is some standard process as well, but organization to organization is differs because some organization, for example, say, oh, I want to complete my shipping within 2 days, but somebody says, some organization says 3 days is okay for me. So that really differs from organization to organization. Then we have central line. This is calculated mean value. This is mean value. How all these things will be calculated, I will actually show you in the process how it is going to be done. Then you have specification limit. These limits are defined based on organization risk appetite and customer expectations. It is possible to associate the penalties when certain data point crossed the limits. So this is again, as I said, specification limits based on organizational process input. Then you have rule of 7. The process is considered out of control and need investigation when 7 consecutive data points are plotted on either side of the mean. I will tell you what is the 7 rules and how it is really considered a challenge or an alert for you. Guys, this video is going to be a little longer, so please stay connected and watch it till end just to understand completely control charts and rule of 7 and how we are controlling, how we are creating these control charts. So rule of 7, I'll tell you what does that mean. And also any data point crossing the UCL or LCL needs to be investigated. That will help you to give about special conditions where you can really define. For example, your delivery may really get delayed in case of festive season. So there you need to maybe hire additional people, or maybe tell your customer, sorry boss, we cannot deliver on so and so time. So this will help you to define your process accordingly. These are some of the components, some of the steps, how to create control charts. I'm going to show you specifically in Excel by creating one control chart so that you can really create for yourself. So the first is take average, second is calculate standard deviation, third multiply standard deviation with 3. You can really check this, okay? Fourth is calculate UCL, fifth is calculate LCL. This is formula average plus standard deviation multiplied by 3. Okay. Then draw chart and format chart. These are only steps, very simple one. So let me show you how it is to be done. I have already created one data for you. So if you can say like this is delayed delivery, or you can call it delivery, day delivery. I'm apologies. This is day of delivery. This is average, standard deviation, UCL, LCL. Okay. So day 1 to uh, this is day, this is delayed delivery. Okay, it is like this. I made a little mistake. Okay, day 1, 2 were the delayed delivery. Let me just make it composite number. Okay, 2 were delayed delivery and average is 3.2. How it has come? You forget about these all columns. Look at this data only. Day 1 2, day 2 2, day 3 3, day 4 5, day 5 3. So these are the delayed deliveries. Then what I did, I calculated average. Simple formula is average of this. So this is my average 3. Now calculated standard deviation. Standard deviation is statdev.p f2 to f21. Again I calculated standard deviation for this. So my standard deviation is 2 and my average is 3. So if you remember, then I said you need to calculate average. So what I did, I calculated average here and I just entered average using dollar because I have to have same value against each day. Then I just put standard deviation from here again using dollar value, dollar and again putting same values here. Now I am calculating UCL. So what I am doing, I can do from here also, it's fine, but what I did, I took this plus H2, this one multiply by 3. So this is the value, standard deviation. Okay, so I am putting standard deviation here and I am putting LCL here. So this is basically LCL again, it is multiplied by 3. Okay, so you can see G2, $G2 S2. So G2, this is the value, this one, this is average, and it is multi. If I don't use dollar also, it will help. So this is lower control limit. After defining these control limits, day 1 delayed delivery, I calculated average, I calculated standard deviation, I calculated upper control limit, I calculated lower control limit, and then I selected the data, and you can simply press F11. This will give you chart something like this, and you can really format the chart. So the red one is showing average, yellow one is showing upper control limit, blue one is showing lower control limit, and axis is day 1 to day 20. Blue is my actual monitoring. You can see here. Blue is my actual monitoring. See, these are delayed delivery. So these are the values here. You can see. Okay. These are the values here. You can see this is the data for these values. Now, if your 7 continuous data point are on either side of your average, then you will call it rule of 7. That means your process needs to be revisited. It is not consistent. So basically your process should go like, heartbeat, up down up down up down, then average. So you can see 2 1 1 2 5 6 7 8 4 da, 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 da. Basically your process is really working great because rule of 7 doesn't apply here. Had it been 7 data point here or here, I'm in upper control limit band or lower control limit band, then rule of 7 applies, and you need to really visit your process to find where the problem exists. This is overall process to create upper control limit, lower control limit, or we call it jointly control charts under 7 tools of quality. If you have any question pertaining to this, please drop in the comment box. I will reply that. So this is a control chart, and I was talking about here. So these are the step I have taken. First I took average, then calculated SD, then multiply by 3, then calculate upper control limit average plus standard deviation multiply by 3, then calculate. So you can skip step number 3 also. Calculate lower, it is minus. Okay, you must understand, when we say UCL it is plus, when LCL it is minus. It has to be minus because when minus you are multiplying standard deviation multiply by 3 and then you are doing out of average, then only you will be able to identify the lower control limit. It has to be subtracted from here. Then you draw the chart and then you format the chart. So the dots you are looking at this, so this is nothing but I formatted the chart. This is formatted by me. I formatted this chart. So if you want to, for example, I don't know, I mean, I can take a separate session altogether for formatting and all. For example, I don't want to show blue here, let's say. So I can really go and format the data labels, and I can fill, I can do anything, I can change, I can do. So you can, you can, so it is automatic. I can change it to maybe red, like this. Okay. So you can change the box also. Currently I change the text box, but you can change the box also. So this is overall process which I was talking about. This is control chart, and I hope you really must have enjoyed this particular video. In next particular video I'll talk about check sheets. So guys, stay connected with my channel Aman Watts, and sorry for being this long video, but I hope you must have enjoyed it. You could really understand what control chart means. Thank you. Subscribe Aman Words. Take care. Bye bye.